Is there really life on Mars? And when will we be able to go there? What have the rovers discovered in the past year? And yes, the scientific community is buzzing. Why? I'm going to tell you about the latest mind-blowing discoveries, the traces of life, and even water. I've saved the most interesting part for last, so I recommend watching until the end. Where do all these photos and videos come from? Rovers play a key role in exploring the red planet. Their mission goes far beyond simply examining the surface.
We do not care.
They help NASA understand Mars's past, its geological features, atmosphere, and potential habitability, critical for preparing future manned missions. Rovers provide data that helps scientists detect traces of ancient life and possible resources for future settlers. As of September 2024, 2 active rovers are operating on Mars, Perseverance and Curiosity, both belonging to NASA. Perseverance, which landed on Mars in February 2021, is exploring Jezero Crater, collecting rock and soil samples for a future mission to return them to Earth. Its goals include searching for traces of ancient microbial life and testing technology to extract oxygen from the Martian atmosphere for future manned missions. Curiosity, active since 2012, has been studying the planet's geological features, particularly the region of Mount Sharp, continuing to provide valuable data despite more than a decade of service. China's Zhurong rover, which was China's first successful Mars mission in 2021, was also recently active, but went into hibernation in 2022 due to dust accumulation on its solar panels. The likelihood of its reactivation is low, I'd say practically zero, but who knows? Maybe we'll head to Mars ourselves soon. Why do scientists choose rovers instead of just using telescopes or satellites?
Women.
Rovers allow NASA to conduct unique experiments that aren't possible with orbiters or stationary landers. Thanks to their mobility, these machines can explore different regions of Mars, paving the way for future manned missions. Perseverance, for instance, is collecting key samples for the project to return Martian material to Earth, which will be a major milestone for science. Can you imagine that? Or how about the experiment to extract oxygen from the Martian atmosphere? This is real preparation for future colonies, where autonomous oxygen production will be critical for astronauts' survival. And rumor has it, we only have a few more decades to wait. Moreover, rovers help study the planet's surface, its composition, and history. They gather important information about how Mars has changed over time, providing evidence of ancient rivers and lakes. Such data not only bring scientists closer to unraveling the possible existence of life on Mars in the past, but also help us understand what resources the planet might offer in the future.
Why you have to be mad?
In this way, rovers are NASA's eyes and hands on Mars, delivering vast amounts of information and preparing the groundwork for the next step, sending humans to the red planet. I'd volunteer for such a mission. How about you? Let me know after you watch the video. But how are rovers even built? They are real mobile scientific laboratories designed to explore Mars, its surface, climate, and potential habitability.
Boom!
These devices are equipped with numerous technologically advanced components and systems, making them some of the most unique and multifunctional machines ever created by humans. The core of the rovers is their chassis and wheelbase. A specialized suspension system allows them to easily overcome large rocks and other obstacles, which is critical given the challenging Martian terrain. The energy sources for these robots are also diverse, from radioisotope thermoelectric generators to solar panels. RTGs are perfect for missions in remote or shadowed areas of Mars where sunlight is limited or absent.
Wow!
The scientific equipment on rovers includes high-tech cameras, spectrometers, and lasers that analyze the composition of rocks and soil. Instruments like RimFacts help search for water or ice beneath the surface, which could be key to understanding the possibility of life on Mars. Particularly interesting is the experimental MOXIE device on Perseverance, which is testing the ability to produce oxygen from Martian CO2, as I mentioned earlier. The process of building rovers involves complex design and numerous tests in laboratories, where each component is carefully checked to ensure its reliability in the extreme conditions of Mars. After all, if any mechanism or system fails, all the data and samples would remain stranded on the red planet. Scientists can't afford such risks. By the way, speaking of discoveries, what's been found recently? Among several recent findings, the rover discovered pure sulfur rocks, seen for the first time on the red planet. This discovery by the Curiosity rover is truly astonishing and unexpected, with potentially significant implications for understanding both the geological and possible biological history of Mars.
We got him.
This finding is especially important because the sulfur was found in its unbound form, as pure crystals, which is unusual for known geological processes on Mars. In the Gades region, which Curiosity is exploring, sulfates, salts that contain sulfur bound with other elements and form through the evaporation of water, had been previously identified. However, until now, pure sulfur had never been observed. The discovery of fields of bright yellow sulfur crystals raises questions about what unique and previously unknown conditions could have formed such deposits. Sulfur is generally associated with the smell of rotten eggs on Earth, caused by the release of hydrogen sulfide gas during the decomposition of organic matter. While elemental sulfur itself has no odor and forms under narrow and specific conditions, its presence on Mars in such large quantities could indicate past geological processes previously unknown to scientists, and possibly suggest dense life in the past. This discovery becomes even more significant in light of the fact that the Curiosity rover has been exploring Mount Sharp for many years, with each layer representing different periods in Mars's history. Discoveries like this field of pure sulfur may offer new data to help understand the conditions that existed at different times on Mars.
How?
And that could have supported microbial life. Do you want something even more global? The Gades Valley Channel on Mars, noticed from space even before the Curiosity rover launched, became one of the key reasons NASA researchers chose this area for detailed study.
What?
Scientists believe this channel was carved by repeated flows of liquid water and debris, which left behind a ridge of boulders and sedimentary rocks. These deposits stretched for 2 miles along the slope of Mount Sharp, forming a unique landscape that could reveal much about Mars's past. Studying the Gades Valley gave scientists a unique opportunity to better understand how this Martian landscape changed over billions of years. When Curiosity arrived at this channel earlier this year, researchers focused on determining the causes behind the formation of large mounds of debris rising from the channel's depths. The main hypotheses were that these mounds could have been formed by ancient floods or landslides. Recent data from the rover confirmed that both processes were involved.
I don't like where this is going.
Some of the debris was likely left by powerful water flows, while other mounds may have formed due to local landslides. Can you imagine? Almost like on Earth. Or here's a photo taken by Curiosity in May, showing rocks with pale borders or halos.
You're broke!
On Earth, these halos typically form when groundwater seeps into rocks through cracks, triggering chemical reactions that change their color. An analysis of rocks in the debris mounds showed that rocks transported by water flows often have a rounded shape, similar to river stones. At the same time, some debris consists of more angular rocks, indicating they were deposited by dry avalanches. Over time, water seeped into the accumulated materials, causing chemical reactions that led to the formation of white halos on the rocks. Wind and sand erosion eventually exposed these halos, making them visible on the rock surfaces.
Ah, you're teasing me!
Becky Williams, a scientist at the Planetary Science Institute in Tucson and deputy principal investigator of Curiosity's Mastcam, commented, "It was a turbulent time on Mars. There was a lot of activity here. We see numerous flows in the channel, including energetic floods and debris flows with large boulders. This highlights Mars's dynamic and multifaceted past, which scientists continue to uncover through missions like Curiosity." The presence of water on Mars has always been a central question for scientists, and it seems every new discovery adds more complexity to what we already know about this planet's history.
Wow.
In search of more answers, the Curiosity team eagerly awaited the opportunity to take rock samples from the Gaitas Valley Channel, which became possible on June 18th. Choosing a drilling site was no easy task. They had to find a large and stable rock suitable for safe drilling, which was complicated by the loose and sloped terrain. Eventually, they settled on a rock they named Mammoth Lakes. This rock promised to be of particular interest, as scientists believed it could hold the key to understanding the geological history of water in this region. Using the powerful drill on its 6-foot robotic arm, Curiosity successfully drilled a hole, marking the 41st such hole in its mission. The drilling process turned part of the rock into a powder, which was then transferred to the rover's internal analytical instruments. These instruments are designed to analyze the rock's composition in detail, providing scientists with more information about the materials it's made of and possibly about the presence of water in this region's past. After completing the drilling and analysis, Curiosity continued its journey through the channel, leaving Mammoth Lakes behind and heading toward new geological targets. Every section of the channel may reveal new secrets about Mars's past, and each rock found could tell scientists a new story about ancient climate changes and the possibilities for life on this mysterious planet. But why am I only talking about one rover when there's also Perseverance, which made an incredible discovery of potential traces of ancient microbial life on Mars?
What is he doing?
He's beginning to believe.
Can you imagine? The discovery was made in the Neretva Valley, a region scientists believe was once an ancient body of water, increasing the likelihood of life in the past. A rock, about 39 inches in size, contains long white veins made of calcium sulfate. These deposits may have formed from flowing water, which is itself an important indicator of potentially favorable conditions for life. Even more intriguing is the discovery of spots containing iron and phosphate, each about 1/40th of an inch in diameter, which may be fossilized traces of bacteria. On Earth, similar microstructures are often associated with fossilized microorganisms. This assumption is based on similarities with terrestrial counterparts, where such minerals are often linked to biological activity. Therefore, if these structures turn out to be biogenic, it could significantly advance our understanding of the conditions under which life might have existed on Mars. The importance of this discovery is further heightened by the fact that the rover successfully took a sample of this rock for further study. However, the question remains as to when and how this sample can be brought to Earth for more thorough analysis. At the moment, the details of sample return are not determined, making further research dependent on the capabilities and tools available directly on the rover.
Psych!
Discoveries like this not only excite the scientific community, but also raise new questions about Mars's past, the possibility of life on other planets, and how we can explore these questions in the future. The discovery of potential underground reserves of liquid water on Mars represents a significant breakthrough in understanding the planet's conditions and its potential for future colonization missions. According to recent data collected by the Mars Insight lander, there may be substantial reserves of liquid water beneath the surface of Mars at depths of 6 to 12 miles.
We don't do that here.
This discovery is based on the analysis of seismic activity on Mars, recorded by the lander from 2018 to 2022. Scientists used data on the speed of seismic waves to identify the types of materials through which the waves traveled. This method is similar to techniques used on Earth to search for underground reservoirs of water, oil, or gas. The study results suggest that liquid water may still exist beneath the Martian surface, which could explain where all the water that once existed on the surface of Mars has gone. The planet, once rich with bodies of water, gradually transformed into a barren desert, and it was believed that the water either evaporated or escaped into space. However, the new data suggests that significant amounts of water may have been preserved beneath the surface. This means that future missions could not only confirm this discovery, but also use local water resources to support life and activities on Mars. However, the technical challenges of drilling 6 to 12 miles deep in Martian conditions present significant engineering and financial hurdles. This discovery not only strengthens hopes for the possibility of Mars colonization, but also highlights the need for further research to better understand the planet's geological structure and potential ways to access its hidden water resources. What do you think? When will a human foot step on the surface of Mars? And do you think we can actually establish fully functioning colonies there? Share your thoughts in the comments. I'd love to read them. Also, if you enjoy amazing stories, can write scripts, edit, or narrate videos, check out the Telegram bot via the link in the description. I'd love to collaborate. Thanks for watching.